lesson content starts now. All right, so you should be able to see my camera. My fingers. Okay, there it is. But before, let me show you the exam question. Just 1 second. It will appear with you there. Yes. What? No, that's not what I want. That's not what I want. I always learning new things. Always learning new things. Okay. Not this one. These are the exam papers. Okay, fantastic. But I want to see my face too. I want to see my face too. So move it there. Okay, there, yeah. Fantastic. All right, so question number 1. Let's get it a bit closer. Yes, let's get it a bit closer. Okay, is my face covering that? No. So question number 1 is saying give one other type of substance that can react with an acid to form a soluble salt. Okay, fascinating. So let's go to the camera then. So soluble salts are formed by reacting metal oxides with acid. So what can we put with an acid that when we add that thing, the result is gonna give us a salt? Okay, I could give you many different options. I will give you 2 of them because I think they are the easiest one. Okay, option 1, you can say a carbonate. A carbonate. And what is a carbonate? A carbonate is a substance that has the ion CO3 2 minus in its chemical structure. Okay, so for example, you can have sodium carbonate, magnesium carbonate, calcium carbonate. Okay, any carbonate, when you add it to an acid, it will give you as a result a salt that is soluble. All right, but even easier than that, you can just say a base, a strong base, a strong alkali. And I will give you the most common example of salt, which is table salt. If you remember, table salt, what is the formula for table salt? Sodium chloride. And where is sodium chloride coming from? How can we form sodium chloride? We can use an acid like hydrochloric acid plus sodium hydroxide, and that is going to form sodium chloride, which is salt, is table salt, is a soluble salt plus water. How is that even possible? Well, let's break the acid into its ion and the alkali into its ion. I need to find a solution for the camera because I love it, but it's giving me shadow. You see, it's covering in there. If anyone is into cameras, yes, you can eat the salt. It's fine. So look, sodium chloride, hydrochloric acid, when you break it into acids, it has proton, into ions. Proton plus chlorine minus 1. And the alkali, when you break it into ions, you have sodium plus and OH minus, which is called hydroxide. What is happening in here? That the sodium and the chlorine, they go together, forming sodium chloride, and the hydrogen goes with the hydroxide to form water. So you see, when you combine an acid with in this case, a strong acid with a strong alkali, the result is a soluble salt plus water. Okay? And this is not only happening with with hydrochloric acid and sodium hydroxide. For example, I use this one because everyone knows what is salt. Everyone knows what is table salt because you put it into the food. So you, David, you are saying like put the camera on the side, like here, and then here. No, that is the other way around. So here and then here, like this. Still I have the problem, you see? Still I have the problem. Anyway, I will find a solution. I think I bought like lights, so I will use them next lesson. All right? Yes, I need a light. I will. No, you don't need to buy for me. Anyway, I use that example because that is the most common example, but there are more. I could use another example of an acid, which is very used in chemistry, is sulfuric acid, H2SO4, plus, let's say, a strong alkali or a strong base, which could be potassium hydroxide. Okay? And as I did earlier, I separate the ions. So here I have one proton, and here I have HSO4 minus 1, and here I separate the ions, and I have potassium and hydroxide minus. So this one comes with this one, and this one comes with this one, and the result is a soluble salt plus water. All right? Citric acid, we don't use it in chemistry that much. I mean, it exists and it is present in fruits, for example, but it is not very useful in laboratory chemistry, let's say. All right? Okay, to answer the question, I gave you two options. An acid plus a base gives you a soluble salt. An acid plus a carbonate gives you a soluble salt. Let's go to another question because I don't want to spend more time in just one mark, okay? So, question number 1.2. Sorry. Give the formula of calcium nitrate. Okay. For those who are not very into the periodic table, you probably know that calcium, okay, is in group 2 of the periodic table. It's in group 2. So it is beryllium, calcium, strontium, barium, and radium. Okay? All right? So calcium, when it reacts, yes, we're going to start, we are jumping from higher to foundation. We are jumping from higher to foundation, okay? So calcium, since it is in group 2, this is the element. When it reacts as an ion, it is calcium plus 2. Remember that all the elements, when they react, depends on in which group in the periodic table they are, you can find them, they will react in a different way. For example, group 1, they always react plus 1. Group 2, they're always plus 2. Group 3, they're always plus 3. Group 4, they do not form ions. So for example, carbon, there are no ions of carbon. Group 5, they're always minus 3. Group 6, like oxygen, is always minus 2. Group 7, like fluorine, is minus 1. And noble gases, they do not react. Okay? So calcium is calcium plus 2. And then we have the group nitrate. Nitrate is always NO3, 1 minus. So we have two ions. Calcium plus 2 and nitrate minus 1. What do we do in here? They need to exchange the values. Okay? So it's going to be calcium, we're going to have 1 calcium, and nitrate, we're going to have 2 nitrate. This is the chemical formula for calcium nitrate. Okay? The only key in here is to remember which group of the periodic table you can find calcium. Okay? And then you remember that calcium, since it is in group 2, when it reacts, it is plus 2. is calcium plus 2, meaning that calcium loses 2 electrons to react. Okay? I use the website PMT, which is a website I recommend every single one. Okay, let's jump to foundation, okay? All right. So, this question is about mixtures. If you remember, a mixture... Wait a second. I didn't change the screen. Now. Here it is. What is a mixture? It's a group of one or more substances that they are together, combined, but they are not chemically joined. So we can separate them through what is called separation techniques. Remember that in chemistry, it doesn't matter if you're in key stage 3 or key stage 4, you have studied 4 separation techniques, which are filtration, distillation, evaporation, and chromatography. Okay? Depends on what you are trying to separate, you will use one technique or another one. For example, if you want to separate 2 liquids, you will use distillation. If what you want to separate is a soluble solid from a liquid, you will use evaporation. And if you want to separate an insoluble solid from a liquid, you will use filtration. Okay? Sorry? Sorry guys, Miss Gogman is asking me something.
How long do you have more?
We just started.
Dinner is ready.
We just started. Guys, how long we have left? 10 minutes?
10 minutes?
10 minutes.
Okay. Dinner is ready.
My babies need me.
I need you too.
Okay, fine. So, separation techniques, okay? Depends on what we are trying to separate, we will use one thing or another. Super important, okay? Which is the example of activity we have in here. They gave us different mixtures and we need to use a different separation technique. So for example, we have, I will write the substances and the mixtures and then we go back to the paper. So we have ethanol from ethanol and water. We have salt. We have salt from seawater. And we have different colors. Okay, that's enough. Different colors. Let's go back to the page. Okay, so let's see what separation technique we're going to use for each case. Case number 1. Ethanol at room temperature is a liquid. And obviously, water is also a liquid at room temperature. Okay? Therefore, in this case, we have 2 liquids. You only know one technique that can separate 2 liquids. And this technique is based on different boiling points. What is the meaning of that? 2 liquids, they boil at different temperatures. So you can heat them up, and depends on when one boils and the other one doesn't boil, you can separate those through distillation. I don't have time, but if you go to Google and you check distillation, you will see the whole distillation display. Okay? So, because obviously we have 2 liquids, we are going to use distillation, which, as I said, is separating 2 liquids based on difference in their boiling point. Salt from seawater. Salt is a soluble solid. By the way, guys, I didn't ask earlier. Does the music disturb you? 78 is the boiling point of ethanol. So approx, yeah, 79 is fine. Does the music disturb you guys? It's chill. Wonderful. So, salt is soluble in water, meaning that when you mix salt with water and you stir it a little bit, you cannot separate them just manually. And also, it means that it mixes with the liquid, it mixes with the solvent. So you cannot filtrate it. If you use filtration with salt water, the salt will go with the water. Okay, it's not useful. So we're gonna use evaporation. Sorry, why did I change the color? Evaporation. Which is very straightforward. It's just we have the mixture, we put it next to a source of heat, let's say a Bunsen burner or an oven or whatever you want. The liquid will boil and the salt will stay. Okay? Then you're gonna have the solid without the liquid. And the last one, when we are trying to separate its different colors, like in my pen, the best one is chromatography. Which those who have been in here enough time with me, you know that I love Greek language and Latin language. Chroma in Greek means color. So chromatography is the graph of the colors, which I think is a very beautiful name. Don't you think so? Oh, fascinating. Come on, it's a very beautiful name. It is a very beautiful name. Let's do another foundation question, yes? Good. We all want to do a bit more foundation. We are eager to do more, right? Okay. So, question 1.2, they show us a diagram for filtration, okay? And they are asking us one improvement. Looking at the diagram, and I want to ask you guys, those who are in here, okay? What do you think is the part of the apparatus, the part of the diagram that is missing or that we could improve? Let's see if someone finds the answer. Just write it in the chat if you think you know the answer, okay? The funnel is there. No, sorry. Absolutely, yes, it is. So, you know what? I didn't notice. I thought that triangle thingy was the funnel, but no, you are right. What is missing is the funnel. What is in there is the filter paper. Well done, Waffles 5421. Exactly, that is exactly what is missing. There is no funnel, okay? There is no funnel. And now I will use this opportunity to ask you something else. Process start. I will be able to see what you have sent me in Teams later, okay? Now I cannot enter in Teams. So, if for filtration we have, let's say that this is our diagram. And here we have, sorry, there you go. Sorry, my flask needs to get a bit fatter. Yes. So here we have our flask. Here we have the funnel. And here we have the filter paper. Question, how do we call the part of the separation, okay, that stays in the flask, and how do we call the part of the separation or the fraction that stays in the filter paper? How do we call the liquid that passes through the filter, and how do we call the solid that stays in the filter paper? Substrate? No. Filtrate, yes. So the liquid is called filtrate. That's correct. Filtrate. What about the solid? A bit of jazz always improves the day. No clues? Alright. It is called, no. Precipitate, no. But good try. Good try. It is called residue. Residue. Can you imagine that is in tomorrow exam? Residue. it will be fascinating. Residue. Okay? So close. So close and so far at the same time. Let's continue then. So one more question in foundation and we go to higher and then we go to sleep. Today we need to sleep early, especially those who have the exam tomorrow. You should wake up early in the morning, yes, and do a last minute revision. But do not wake up before 5, please. Complete the sentence. Choose answers from the box. In simple distillation, the mixture is heated to make the liquid. How do we call when we heat up a liquid up to changing its state? Super easy. Come on. Exactly. Evaporate. We obviously evaporate. And the vapor is then cooled to make it. How do we call the change of state from gas to liquid? So from liquid to gas, evaporation or boiling. And then from gas to liquid, condensation. We are going to see condensation, for example, in the clouds when it rains. Is just an example of condensation. Fantastic. All right, so that is foundation sides. I would love to do the 6-mark question, but we do not have time. So we will go to this one, which is in both. Yes, this one is in both, in higher and in foundation. So they tell me that one atom of iron is represented as 5626 Fe. And they ask me, give me the number of protons, neutrons, and electrons in this atom of iron. Those who were in here last week, you remember we did this exact same activity. We talk about what is the atomic number, what is the mass number, and how can we get the amount of protons, neutrons, and electrons from them. So, for example, the number of protons is 26. Why? Because the atomic number tells you the number of protons. Okay? Now, what about the number of electrons? Since they are telling me that this is an atom and it is not an ion, then the number of protons and the number of electrons must be the same. Therefore, there are also 26 electrons. And the last one, which is the number of neutrons, we get it from doing atomic mass, which is 56, minus atomic number, which is 26. 56 minus 26, the answer is 30. So we have number of protons, 26, number of neutrons, 30, number of electrons, 26. And I am so happy that we are almost at 100. I wish I had started Twitch earlier. I honestly think that I should have started earlier, but we are going to have this platform for all the years ahead. So current year 10 when they move to year 11, year 9 when they move to year 10, I will be here helping hundreds of students. And what I want is to make the community even larger, to get people from other schools, to help people from other cities if possible, to help everyone to get better marks in science. Let's go with the last question. Iron is a transition metal. The transition metals, they are the ones that they are at the middle of the periodic table. If you look at, yes, I know, it's something it is in my agenda. It is in my agenda. Anyway, as I was saying, transition metal transition metals, they are the ones that they are in at the middle of the periodic table. Okay, so if you see your periodic table, okay, the ones that are at the middle, all right, those are called transition metals. And they give you the example of sodium to compare iron with sodium, and they ask you to find differences. Okay. That would be fantastic, honestly, if I became and useful tool for all the students in the country. That would be fantastic. So, what difference do we see between iron and sodium? There are many. There are so many, okay? But, for example, sodium is stronger. Sorry, sodium is stronger. Iron is stronger than sodium. Iron is a better conductor than sodium. Iron is less reactive than sodium. Iron cannot be cut with a knife, but sodium can. Iron reacts very slowly with water, but sodium reacts very quickly with water. Sodium reacts very slowly with air, but sodium reacts very quick with air. There are so many differences, okay? Think that sodium is a very, very soft metal and very reactive and has very strong reaction with water. Meanwhile, iron doesn't have strong reactions, it's more stable element, it's much stronger metal. Therefore, you just need to think about, try to remember sodium and iron and take differences from them. Since it is a 2-mark question, you need to give at least 2 differences. Does it make sense? Of course it makes sense. Alright, ladies and gentlemen, we are going to leave it in here. The number of viewers is increasing, and that is a sign for me that you want to go to bed. And I want to go bed too. As I mentioned earlier, those who have exam tomorrow, chemistry, you need to go to bed as soon as possible to wake up a bit early and to do some revision before the exam. Before I go to finally to bed, I will remind my year 9 that tomorrow they have an exam. I will put it in class chart. And to all others, have a lovely evening. If you have any question and you cannot wait for tomorrow, please just send me a message in Teams and I will try to answer it as soon as possible. Have a lovely evening or rest of the evening, all of you. Don't forget to have a good rest. See you tomorrow. Bye bye.